Okay, so this is week 2, Monday, Math 8. We're going to do graphing functions and transformations in reverse. All right, Grayson, go ahead and read. Wait some coffee. A is para function, so it's right here, correct? B, describe each transformation, like you're going up, down, left, right. If it's compressed, that's number 1. That's number 1. It's fine. We're just going to do this one first. Okay. And then lastly, C, finally write the equation of a function that represents the graph below. Do you see the 3 parts right here? Okay. Well, we'll go over that in a minute. Let's do this one first. Okay. All right. Parent function. What shape is this? Parent function. What is this? What do you call this? Function. Okay. Parent equation is y equals what is the absolute value equation of or parent function of the absolute value for that, correct? Yeah. Okay, now describe. Talk about parent function, which that parent function starts at 0, 0. Okay. If this was the actual graph of what I have, this is what it looks like. Do you see how the one that you have is this blue one? And that looks different than the pink one. Pink one is the parent function, correct? So describe, for B, describe each transformation of the parent function. So how did you get from the pink one to the blue one? It did not look like it went left or right. The pink one is the parent function. The parent function starts at 0, 0, and it's just the shape of a upside down V in it. Or actually, I'm sorry, it's not like that. The parent function will look like this. This is the parent function. Do you see that?
Then how did you? Oh wait, no.
The blue one is what's given to you. So draw the parent function first. Use a different color pencil. You need to have different color pencils, Grayson. Yeah, do it in a color pencil. So I can say no movement left or right. Okay. But it did go from the pink one to the blue one. It did look like it go up. How many units did it move up?
3 or 4.
How many?
4.
1, 2, 3, 4. So write that down. And then didn't it also look like it got flipped? But when it's flipped, what is that called? Reflected over which axis? Which means it's a negative A. Does that make sense? Okay. That's all you have to do for that part. Equation of the function. What would your equation look like? Remember, equation is going to be x minus h plus k. If you move 4 units up, where do you replace the 4 at? So do you want to go to a corner somewhere? Well, why don't you give her yours? Oh, you don't need to have one. No, because we don't have it anymore. But if mommy finds another one, I'll give you another one, okay? I love you. So where do I put the plus 4? Where would that go? Where would that go? Where is that? The plus 4. No, the plus 4 does not go to the y value. The plus 4. Which letter? Which letter would that represent? Hey, you didn't pay attention. K is up, negative K is down. Did you not remember this? Did you not go over the work that we did on the video this weekend? You need to do all of it. Do you understand me? This is a basic thing. The fact that you don't know this really disappoints me. What does that do? means you go to the right. Where's the notes that we copied for this? Where's the notebook that you have for this class? Go get your notebook for this class. This is not acceptable, dude. Y equals negative, absolute value, x, there's no h in there because it's not moving left or right, and then a positive 4. Now, when you look at the blue one, does it look like it's a little bit smaller than the pink one? Because you see how the pink one goes through, like, the diagonals right here? Does the blue one look a little bit skinnier? It looks a little bit skinnier. So then which one does that affect? Okay, but what should it be for it to be skinnier?
If it's not in values.
No, it has to be bigger than it. So chances are it could be a -2. Because, and you could say that, another thing you could say here is that shape is what? If it's skinnier? Compressed. Do you understand? Okay, next one. You go ahead and do this one on your own. Look at the notes right there. All right, when you look at this right here, it looks like the size shape of a F. Do you agree? Okay, parent function, what would that be? Good. Cubic function. Parent equation is y equals x cubed, right? And the cubic function starts right there, and it just looks like this. Do you see that? Well, clearly, your graph, which is this purple one, is not that. That purple one is right there. No, it is. It's going down, but it's also going to the left. You're looking at the difference between this blue dot, which is that vertex there, and then this purple dot. Do you see that? So it's going to the left. Because it's shifting. That's what transformation is. You're just basically sliding it around. Transformation just means movement. So looking at this blue dot, how are you going from this blue dot? It looks like it's going this way, and then it's going down, correct? How many steps is that going to the left? How many steps is that going down? There you go. Describing the movement. Move 2 units left. Move 4 units down, correct? It looks like the shape is about the same. Do you agree? Doesn't look like it's wider, not wider, or compressed. Correct? So then my equation is going to be what? Y equals, and it doesn't look like it's flipped, so it's a positive A. So x, it's moving 2 to the left, so that's going to be +2 cubed, and then 4 down, -4. Does that make sense? So I'm going to have you try number 3. What's the name of the parent function? It's a quadratic function.
Yeah.
The parent function is y equals x squared, correct? So then what you want to do is, so this is your actual transformed function. You want to pay special attention where the vertex is, which is that point right here in red. And then your regular one starts at 0, 0, and it looks like this, correct? I can't really tell the difference if this is actually skinnier or about the same size. I would say it's about the same size. What do you think? Or do you think it's wider? It's a little bit wider. Do you feel like it's wider? Like wider? Okay, that's fine. Yeah, so then from the orange, how are you getting to the red? You're going this way and then this way, correct? How many to the right? How many down? Okay, so then you just say down 3 units, right 3 units, and it is wider, correct? Okay, so then your equation in this case should be y is equal to, and it's still facing upward, so it's just, for it to be wider, it has to be, less than 1, correct? So I will just say 1/2. 1/4 means it's really wide, it's 0.25. Does that make sense? Okay, so 1/2 is, and then x, 3 to the right is x minus 3 squared. 3 units down is -3, and that is your answer. Does that make sense? Now let's go into the front of this, okay? This one's a little bit different. So read part 1A. What does it ask you to do? B. Okay. Okay, so perfect. 3 right here is A equals 3. A is greater than 1, correct? Which means the shape, or you should say the function, is what? Compressed or skinnier, right? Next thing you should notice, the 4. 4 is K, correct? Which means it goes 4 units up. Does that make sense? So then you write down the description, okay? And then this is your parent function right here in the red, correct? But with your transformation, okay, why is your, okay, so your transformation, you're gonna go up 4. So 1, 2, 3, 4, and it's skinnier, so it should be like this. Does that make sense?
Yeah.
Great. Now finish up the description right here, okay? Does that make sense? And then go on to number 2.
Says so.
That's the one. You're doing good.
So, so it's basic down set. And it shifts to the right one time. Or one bit.
Good. So I'm gonna go ahead and use this one right here, so you can go ahead and read what I wrote. Hold on. Oh, crap. Okay, so read that, please.
The function y equals actual value x and y.
No. Is
It's vertically stretched by 3 narrower because
and then shifts.
shifted up 40.
Does that make sense? That's just another way of saying it. Okay. All right. So for number 2, looking at this right here. All right. So what do you see here? There's a negative. Yeah. So the negative means what?
It's
Yep.
Is it always reflecting over the x-axis?
Yes, reflect over the x-axis. And then also, if A is 1/4, A is less than 1, which means what?
It's wider.
And more stretched, right? Okay, next one. We have this -1. What does that mean?
It's just to the right 1 unit.
Good. So then here we go. You have your parent function right here as 0, 0, correct?
How do I know that a is greater?
If A is greater than 1, that means A is equal to like 4, right? So you have y equals 4, x minus 1 squared minus 2. Does that make sense? That 4 right there. It doesn't matter. Even if it has a -4, it just means it's going to be, 4 means that it is going to be skinnier, correct? It'll just look like this. Do you see that? It's just skinnier. So then this one is just to the right 1. It's not going up or down, correct? But it is negative, so it's upside down, and then it is wider, a lot wider, buddy. A lot wider. You see how wide it is? Good.
Okay.
And it's shifting to the right. 1 unit. Correct? So that's something that you can write for that. All right. Number 3. Did you do number 3 yet?
No.
You didn't do number 3 yet? Oh, hold on a second. I screwed this up. Sorry, I made this mistake here. Hold on. I actually copied the wrong one. Hold on. Here we go. It's not a big mistake. Is reflected over because of negative sign. Vertically compressed. It's not compressed. It's stretched by a factor of 1/4, making it wider, and shift 1 unit to the right. That's what you can write. Okay. Does that make sense? Okay, number 3. This one is an exponential function, correct? This 2 is just the base. You don't change that because remember the parent function is y equals 2 to the x. Does that make sense? So that doesn't change anything with it, okay? But what does change is this 1/2. What does that do? A is smaller than 1, so A is going to be wider and stretched. Does that make sense? Okay. And then you have the 3. What does that 3 mean?
It shifts to the right.
Good. Okay. So then your original one is going to be like this right here. Or it's actually, yours is actually kind of, yeah, okay. It's right here, correct? And then so your other one is, well, actually, let me see. The parent function. What is the vertex of the parent function of a function? So the starting point is 0, 1. You understand that? That's the starting point, okay? So for the parent function, it is starting at 0, 1, right there. So remember, just remember that the parent function is at 0, 1. You understand? Okay, so then from that parent function, you're gonna go 3 to the left. So 1, 2, 3, and down 1, 2, 3. Do you see that? And then it's gonna be wider. So like that, I guess. Does that make sense? Yep, and that's it. And then write down your description. So what's your description?
Doesn't it shift to the right 3 units?
No, because it's a positive 3. So it's left 3. When you have x minus h, a negative h is to the right. A positive h is to the left. That's okay. But does that make sense? Good. You need to make sure you memorize them. Okay, that's kind of important, buddy.
What about the 2 though?
Okay, I just told you the 2 is part of the equation. That doesn't change. It doesn't affect anything. It just starts at 2. However, okay, let's see what happens if you put a 3. This is why we use decimals. So go to decimals. Oh, I don't know that. So here, Oh my gosh, like seriously, what the hell is this? Graph calculator. So y equals 2, and then you want to go over here and put x. Do you see how it starts at 0, 1, right? That is the or the vertex. Do you see that? Okay. Now your equation was it y equals, was it 1 over 2? And then it was 2 x. Now look over here. Do you see how that's changing? That's like half. The vertex now is at 1/2. Do you see that? Okay. What if it's y equals 4 to the x? What happens then? What do you see happening? Yeah. Now let's see. Does this make a difference if you do y equals 1 over 2, 8? Because what's 1/2 of 8? Isn't it still 4? Let's see if this line is going to be the same color as the green one, as the one before. Does that make sense? Is there a little bit of difference? There's a little bit of difference. You see that? It's a little bit nearly the same. Yeah. Okay. All right. That concludes everything. Are you okay with it? Did you look at the description that I wrote? Okay. Make sure you have something similar to that. Okay. All right. That's it.